Thank you very much for inviting me to this talk and for this nice introduction. What I would like to do is to recap some of the key learnings I've had by looking at comprehensive data sets that cover the diffusion of technologies in the past that I've co-developed with co-authors like Bar Hobain or with Xavi Sirera and Marcio Cruz. And once we understand what are the key patterns in the data and the key determinants of the relation between technology and productivity, to draw some implications for AI. Okay, so first question that I would like to think about is, how does the arrival of a new technology, affect productivity growth? Okay, and to answer the question, basically we have to think about two dimensions that determine that relationship, the relationship between the arrival of the new technology and productivity growth. The first one has to do with how long it takes for the technology to arrive into the country. That's the adoption lag. And the second relevant dimension is, once the technology has diffused, how intensively is it being used? Okay, and so that's the intensive margin. So if you look at the data, here is some actual data on the diffusion of computers in the US in blue and in Vietnam in red. Okay, and so what you can see is that these two curves that represent the diffusion of computers in these two countries, they have similar shapes, and to a first order, they differ in a horizontal shift and in a vertical shift. Okay, so there are two. To first order, we can think of diffusion across countries as captured by these two dimensions. This horizontal shifter reflects the adoption lag, which measures how long it takes for new versions of the technology, including the first one, to arrive into the country. And these vertical shifters capture this intensity of use once the technology has diffused in the country. So looking at data on the diffusion of many technologies in over 100 countries over the last 200 years, with Bar Hobain and with Martin Mestieri, I've been able to understand what are the key patterns of technology diffusion and how they have changed over these last 200 years. Okay, and so here, and with regards to these adoption lags and this intensity of use. Okay, so with regards to adoption lags, the first thing that you notice when you take the average of the adoption lags across these different technologies and across all these countries, is that on average adoption lags are very long. Okay, they are of 40 years. However, they differ quite a bit both across countries and over time. Okay, so in this plot, what I'm doing is I'm focusing on 25 big technologies invented over the last 200 years, starting with spindles and steam and motorboats and ending with the internet and cell phones. Okay, each bar represents one technology and its place in the invention year of the technology. And each bar has 2 points. These 2 points represent the adoption lags, the median adoption lag, in two different sets of countries. What Madison called Western countries, that's the bottom bar, and the rest of countries, okay, which is the top bar. Okay, so this is like the median adoption lag for spindles in Western countries and in non-Western countries. And so what you can see is that in every single technology, the median adoption lag is shorter for Western countries than for non-Western countries. It's not surprising. But what is more interesting is that adoption lags have decreased over time. Like, when you have technologies invented 10 years later, the average adoption lag is 4 years shorter. Okay, and this pattern is a pattern that started with the Industrial Revolution. It's not something that has happened now with digital technologies. It has been very gradual. It's a linear pattern. Okay, now interestingly, the rate of reduction of adoption lags, this relationship between the adoption lag and the year of invention, is steeper for non-Western countries than for Western countries. Okay, so adoption lags have decreased everywhere, but they have decreased more in non-Western countries, which, in other words, like, there's been convergence, strong convergence in adoption lags. Okay, now technologies arrive quickly everywhere, and so that's perhaps more surprising, given that when we look at productivity, we haven't seen any similar convergence in productivity. Okay, productivity has diverged. While adoption lags, which is an important dimension of technology diffusion, have converged. Okay, and so you may wonder, how is it possible that adoption lags have converged while productivity has diverged? And the answer has to do with the intensive margin. Okay, so if instead of looking at this first dimension, the adoption lag, you look at the second dimension, which is the intensity of use, you have to normalize it to our economy. So I'm going to normalize it to the US. So I'm going to measure the intensity of use for Western countries relative to the US and the intensity of use for non-Western countries relative to the US for the same 25 technologies. And what you see now, the top is the Western countries, the bottom is the non-Western countries. What you see is that adoption lags, sorry, the intensity of use is always larger in Western countries than in non-Western countries. Again, not surprising. But perhaps more surprising, the gap in the intensity of use between Western and non-Western countries has increased over time, has increased. It's much larger for newer technologies than for technologies invented 200 years ago. Okay, and so that's an important fact, the divergence in the intensity of use between Western and non-Western countries. Okay, now what does this imply for productivity growth? Well, if you go back to this period of time, the last 200 years, in terms of productivity dispersion across countries, one key fact that has been widely studied in development and in history is the so-called Great Divergence. Okay, what does the Great Divergence mean? Well, Great Divergence basically what it means is that when you look at the distribution of income per capita or productivity across countries, so here I have it in this top left chart for 1820, I have 5 quintiles, and I'm measuring productivity or income per capita relative to the average income in the bottom quintile. So what you see in the dashed red line is that there were not very large difference in productivity back in 1820 across countries. So basically, the ratio of productivity between the top quintile and the bottom quintile was a factor of 2.8. Okay, relatively small. And however, 200 years later, that ratio was a factor of 28. So it was 10 times larger. Okay, that's the so-called Great Divergence. Now, you may wonder what caused this Great Divergence. And so one exercise that I conduct with Martin Mestieri is to take these patterns of technology diffusion and to plug them into a simple model where there is a common frontier of technologies that the arrival of technology is exogenous and accelerated in 1765 with the Industrial Revolution, and countries adopt technologies according to these adoption lags that we have estimated in the data and implement them according to this intensity of use that we have estimated in the data. Okay, and when you take that simple model and you simulate it, what you see is that first, the model does a great job in explaining the initial distribution of productivity across countries. This is the blue line here. But perhaps more surprisingly, given that we have estimated all these technology diffusion patterns using micro level data, country specific and technology specific data, the model does a fantastic job in replicating the Great Divergence. Okay, so you can see how over time the distribution of productivity across countries it tracks very nicely the actual data. Okay, which is something that is surprising given that there is nothing in the model that is hardwired for that to happen. Okay, and so in particular, in addition to tracking well the data, what this means is that the model, despite of this convergence in adoption lags, the impact of the divergence in the intensity of use of technologies is so strong that it's sufficient to generate the divergence in productivity that we have seen in the data. Okay, so in other words, this intensity of use is really important to understand the impact of technologies on productivity, or the adoption of technologies on productivity. Deserves further scrutiny. Okay, so several years after finishing this study, I work with Xavi Cirera and Marcio Cruz to dig deeper into this intensity of use. Okay, and in particular, if you think about the intensity of use, it's the convolution to some extent of two dimensions. One dimension is, okay, once the technology has arrived to the country, how many establishments do adopt the technology? And second, given that an establishment has adopted a technology, how intensively, how widely is how it uses this technology, okay? And so these are two different dimensions in principle that are worth measuring. Now, how would you measure those? Well, what we do with Xavi and Marcio is to adopt a task-based production function, okay? So first we think about what activities each establishment conducts, and we group them in so-called business functions, okay? And then for each of these business functions, we think about what possible technologies can be used to conduct the business function, okay? And that gives us a structure, a two-dimensional structure that we call the grid, okay? Now, the grid that we construct, it encompasses 63 different business functions. 7 of them are general. That means that they are relevant for any establishment in any sector, and 56 are specific to 12 broad sectors in the economy, okay? And overall, the grid comprises over 300 technologies, okay? And we go and we collect data on 21,000 establishments, which are representative samples in 15 countries. So let me talk a little bit more about the grid so that you get a better sense of what it is. So here I'm showing you the grid for the general business functions. These are the business functions that are common across sectors. And so they comprise the administration, production planning, sourcing and procurement, marketing and product development, sales, payment methods, and quality control. Okay, so these are activities that any establishment, whether you are a farm or whether you are like Microsoft, you need to conduct one way or the other. Now, how you conduct it is going to differ because you will use different technologies. Okay, and so this vertical dimension covers the range of possible technologies that you can use to conduct the key tasks in each of these different business functions. Okay, so in particular, for example, you can conduct your administration using pencil and paper. You can use it with a computer with Excel. You can use it with some mobile app or some digital platform. You can use it with computer and some specialized software, say an accounting software. Or you can use it with an ERP system, an enterprise resource planning system that integrates all of these functions that have to do with administration in just one software, and you just feed in the information once. Okay, so these are different ways in which you can conduct these key tasks in administration, for example. And each of these different technologies, they are ranked in terms of their sophistication. Okay, the top technologies are the least sophisticated, and then as you go through the ladder, then you're going to end up in technologies that are more and more sophisticated. Okay, so what we go is we go to the countries, we go to each establishment, and we ask them which technologies do they use for each of these to conduct the key tasks in each of these business functions. And of those technologies that they use, which is the one that they use most intensively, most widely, okay? And so when you look at the data, there are a few things that stand out. The first one is that establishments tend to use more than one technology to conduct the tasks in a given business function, okay? On average, they use 2 technologies. The majority of establishments, more than 63% of the establishments, they use more than one technology to conduct these activities, okay? Second thing that stands out is that establishments don't tend to skip technologies, okay? If they use handwritten processes and they use a mobile app, they will also use a computer with Excel, okay? They don't use a computer with Excel and they jump all the way to an ERP system, okay? They go gradually from one to the next, and you don't have gaps there. Okay? That's important because it suggests that the adoption of technologies is something gradual, and there is no leapfrogging. There is no space for leapfrogging. It's not that you can skip all of these technologies because you are a laggard and suddenly you're going to jump to an ERP system, okay? That's important to understand the relationship between productivity, technology and productivity. Okay, now, of all of these technologies that we measure, we focus on 2, okay? The first technology we measure is focus on is the most sophisticated technology that an establishment has adopted in a business function, okay? And we call that the max technology, okay? We can assign a sophistication to that technology by creating a scale that goes from 1 to 5, which is linear, okay? And so the sophistication of that more sophisticated technology that the establishment uses, we call it max, okay? Now, the second technology we focus is the technology that the establishment uses most widely in conducting the task of a particular business function, okay? And we call that technology most, okay? So most is the most widely used, max is the most sophisticated technology available in the establishment. And so it's important to understand, like, these max and most, they connect to this dichotomy, these two dimensions that I explained you that have to do with that determine the intensive margin, okay? Max determines which is the technology that you have adopted, and most tells you like which is the technology you are using most widely, okay? Okay, so we analyze whether there are max-most gaps in the data or not. That is, whether the most widely used technology is the most sophisticated technology available or not. And what we find is that these max-most gaps are very prevalent. On average, establishments that use more than one technology have max-most gaps in 62% of the instances. Okay, here I'm plotting the distribution of the frequency of max-most gaps across establishments. And you can see that the majority of establishments have a very large fraction of their business functions with max-most gaps, okay? Also, when you look across countries, in all countries, whether they are poor or rich, the majority of business functions have max-most gaps. However, the incidence of max-most gaps, it's related negatively to income per capita. In poorer countries, the frequency of max-most gaps is much larger than in richer countries. Okay. Now, max-most gaps are important because of two reasons. First, in principle, they would be important for two reasons. The first is if the drivers of adoption and the drivers of the intensity of use were different, okay? In that case, like, we care about the presence of max-most gaps. To establish whether the drivers of adoption and the intensity of use are different, one of the things that we do is to look at the relationship between the number of technologies used in the business function and max and most, okay? And what we see is that there is a close to one-to-one relationship between the number of technologies that you use in a business function and max, which suggests that when you bring a new technology into the business function, that technology typically is better than the technology that you have available for production, and hence it pushes max by close to one, okay? However, the relationship between num and most is much smaller, so it's very far from one. Like, basically, when you bring a new technology to the business function, that technology barely changes the technology that you are using most widely, the technology that you are using to conduct the key tasks in the business function, okay? Again, that suggests that the technology upgrading processes that determine mass, i.e. adoption, are very different, or is very different than the technology upgrading process that affect the intensity with which you use a sophisticated technology, i.e. most, okay? So that's the first reason why you care about this distinction between the drivers of these two dimensions are different. The second reason why you may wonder, where you may be interested in this distinction, is if the relationship between max and most and productivity is different, okay? And so to do that, to study this, what we do is we look at productivity regressions at the establishment level in our sample of establishments. And what we find is that max, it's almost uncorrelated with sales per worker, okay? However, most is extremely associated, is strongly associated with sales per worker. Indeed, in an accounting sense, in a development accounting sense, most accounts for a very large share of the cross-establishment variation in productivity, okay? So most is much more relevant than max. The intensity with which you use a technology is much more relevant of whether you have or don't have the technology available in the establishments for productivity dynamics, okay? This table is our way to think about the solo paradox, okay? So solo say that computers are everywhere other than in productivity statistics. Well, the presence of technology is max, okay? And max is really not moving the needle for productivity. However, once you start using them intensively, once you start like, really extending the use of this sophisticated technology that you have adopted, then it really moves the needle, really affects productivity, okay? So that's basically how we think about it. Okay, so in summary, what we have seen by looking at this technology analysis, the use of technology at the establishment level, is that establishments don't skip technologies, therefore there is no leapfrogging, that most gaps are the norm. They're present in the majority of business functions that use more than one technology. That max and most are driven by different technology upgrading processes, and that most is much more relevant than max for establishment productivity, okay? So at this point, I think we can take stock and move to think about AI, okay? Okay, so the first thing that I think we should reflect is how will AI affect production processes, okay? Like, in abstraction, step back for a second, let's think, when we bring AI into the production processes, how will the actual production of things will change, okay? Now, given the structure of production that the conceptual framework I've been presenting here, I think there are two possibilities. One possibility is that the arrival of AI is going to change dramatically the way we think about business functions, okay? Suddenly, there will be business functions that will be obsolete, that we will not do anymore, or there will be new business functions, new set of tasks that we haven't considered, okay? I think that the first option, eliminating business functions, probably is not going to happen, because in reality, like, all of these things that establishments conduct are necessary for production, okay? So I don't think that the arrival of AI is going to make them irrelevant. It's possible that in a few years, there are new dimensions of production that become relevant that are not captured by this business function structure, the current implementation of this business function structure, these columns that we have measured in the grid, okay? That's a possibility, but probably will take a while. Now, a second way in which AI may affect production is not so much by changing the columns, okay, but by changing the rows, okay? And this is like a very real possibility. What will happen is that when we do the administration, until now, the best technology available we had was an ERP system. But now, the new ERP systems that will appear, they will have AI integrated in them, okay? And that will allow us to conduct a series of activities that are more sophisticated, or the activities that we're conducting them, it will allow us to do them better, okay? So for example, like, when we do marketing, now instead of having just a CRM, now we'll have the CRM integrated with AI, which will allow us to optimize the way we interact with our customers. And maybe there will be some big data analytics which are integrated with AI that will allow us to understand better the marketing strategy that we need to conduct, okay? So other examples that we have, for example, if you think about retail, okay, the functions in retail, the relevant functions are customer service, pricing, merchandising, inventory, and advertisement. These are the sector-specific business functions. And now maybe when you do your inventory, you will have some AI that you can plug it into your system that will allow you to optimize and make smart forecasts about future demand that will be much more accurate than the ones that you have right now, okay? So in a nutshell, one way to think about the impact of AI on production is by thinking along the lines of this grid and thinking of AI as additional rows that are more sophisticated than the previous more sophisticated technologies in the grid, okay? Okay, so with that framework in mind, we can study what are the relevant dimensions that will determine how the arrival of AI will affect productivity, okay? And based on the conceptual framework I've presented, there are three relevant dimensions, okay? The first one are the adoption lags at the country level, how long it takes for AI to arrive to a country. Second dimension has to do with max. It has to do with whether establishments implement AI or not, whether establishments adopt AI or not. And the third dimension has to do with most, okay, which is once we have implemented AI, are we go in a particular business function, are we using it very widely, or its use is mostly marginal, okay? So these are the three dimensions that will channel the relationship between AI and productivity growth, okay? So what can we say from the data with regards to these three dimensions? Well, the first thing we can say is that if you look at these dynamics for adoption lags, what we have seen is that at the country, when you look at adoption lags at the country levels, those have become very, very small for the more recent technologies, okay? And what we are seeing is that the moment a new AI technology is introduced, somebody in the country adopts it immediately, okay? So these country level adoption lags, they are close to zero. They are going to be, they are going to have, they are going to facilitate the implementation of technology at the country level. What about the use of technology at the establishment level when it has arrived to a country? Well, for that, we're starting to learn how countries are using, how establishments are adopting AI. And we, my co-authors at the World Bank and me are measuring it in a number of countries. So this is like data just out of the oven from Romania, a survey we are collecting of representative firms in Romania. And what we are seeing is that the majority of the establishments, they are not using at all AI, okay? So basically, 86% of the establishments, they have absolutely no use for AI at this point. And so what that suggests is that probably, like, this is not just one case, it's like, that's, I think, the general pattern. Most establishments in most countries are not using AI at all. So max is still very far from reflecting AI, okay? Now, what about those establishments that use AI? How intensively do they use it? And so, again, we're starting to learn about that, but the reality is that even those that implement AI, they are using it marginally, okay? Here I have a measure of the intensity of use, which has to do with the fraction of the workers in the establishment that are using AI. And the reality is that even in those that implement AI, the majority of establishments have very few workers, a small share of the workforce using AI, okay? So even when max reflects AI, most is not really reflecting AI in the majority of the cases, okay? Now, you may wonder, well, this is just a matter of time. It would be just a matter of time that those establishments that have adopted AI are going to extend the use widely, okay? Well, that's a possible hypothesis. And what do we know from the data? Is it just how relevant is time to think about the max-most gap, okay? Well, in the data, what we have seen is that time is not a key driver of these max-most gaps, okay? In particular, when you look at the distribution of adoption lags at the establishment level, so how long ago you adopted the technology, and you compare this distribution for establishments that don't have max-most gaps, okay? Functions where you don't have a max-most gap. And for functions where you really have a max-most gap, so those are in blue, the other ones are in red, what you see is that the distributions of adoption lags, they are not very different. That means that the time since you adopted the technology is not a key driver, it's not a fundamental driver. It affects a little bit, but it's not, in the big scheme of things, it's not a fundamental driver of whether you're going to extend the use massively of the technology or not. That reflects other things that have to do with the strategies of the firms. It has to do with the quality of management. It has to do with the access to specialized inputs, human capital, physical capital, and it has to do with the access to high value added demand, okay? So those are more relevant drivers of whether you extend the use of the more sophisticated technologies that you have or not, than how long ago you adopted the technology, okay? So recapping, what can we say here? Well, what we can say is that technologies, including AI, have arrived quickly to every country, okay? Now, within countries, they don't diffuse nearly as fast because adoption is gradual and establishment don't skip technologies, they don't leapfrog, okay? Now, once they adopt the technologies. What we see is that typically they don't become widely used, okay, in most establishments. And in some establishments that have adopted technologies, they will never become widely used, okay? That's something that we see, it's typical. And so one conclusion that this means is that AI is going to cause significant divergence in productivity between those establishments that use widely technologies and those that either don't adopt it at all, or if they adopt it, they don't use it widely, because at the end of the day, that's the dimension that matters. Thank you very much for your attention.